According to the National Electrical Code, or NEC Article 400.7, flexible cord is permitted for use in certain wiring applications. These applications include using hard service cord, such as Type S, SO, SJ, SJO, SJT, SW, STW, STO, SJTW for pendants, hook-on cords, appliances, portable tools, and control circuits. Other flexible cords can be used for specific applications such as elevator cables, designated as Type EO or ET, theater cables, Type TC or TPC, heating cables, Type HC or HPN, and mineral insulated metal sheaths cable, designated as Type MI. The NEC does not specifically require that motors and limit switches be wired with flexible cord. However, it is a common practice in industrial applications for several reasons. Firstly, it allows for easy movement and connection of motors and equipment. Secondly, flexible cord can withstand repeated flexing and bending. Thirdly, it provides resistance to oil and moisture, which are common in industrial environments. When using flexible cord for motor and limit switch wiring, several factors are important. Firstly, select a cord with the appropriate gauge, insulation, and outer jacket for the application, ensuring it can handle the voltage, amperage, and environmental conditions. Secondly, use strain relief fittings to prevent damage to the cord where it enters the equipment. This prevents the conductors from being pulled from their terminations. Thirdly, secure the cord properly to prevent it from being pulled out or damaged. Use appropriate clamps or supports. Fourthly, protect the cord from overloads and short circuits by using correctly sized fuses or circuit breakers. In addition to the specific requirements for motors and limit switches, the NEC provides general guidelines for the use of flexible cord. Flexible cord should not be used where it is subject to excessive heat or cold, abrasion or cutting, or continuous mechanical stress. Flexible cord should be protected from damage by conduit or other enclosures, cable trays or raceways, and wire clamps or other supporting devices. To summarize, while the NEC does not explicitly require that motors and limit switches be wired with flexible cord, it is a common and acceptable practice in industrial maintenance. Following the code requirements and guidelines for flexible cord use ensures safety and proper performance. Always consult the latest edition of the NEC and local electrical codes for specific requirements in your area. When selecting a flexible cord for motor or limit switch applications, consider the following factors. First, the voltage and current requirements of the equipment. Second, the environmental conditions such as temperature, moisture, and exposure to chemicals or oil. Third, the degree of flexibility required. Fourth, the mechanical stress the cord will be subjected to. There are various types of flexible cords available, each with different characteristics and suitable for different applications. Some common types include Type S, which is a hard service cord designed for heavy-duty use. Type SO, which is an oil-resistant hard service cord. Type SJ, which is a junior hard service cord. Type SJO, which is an oil-resistant junior hard service cord. Type SINT, which is a hard service thermoplastic cord. Type STO, which is an oil-resistant hard service thermoplastic cord. Type SJT, which is a junior hard service thermoplastic cord. Type SJTO, which is an oil-resistant junior hard service thermoplastic cord. The insulation and outer jacket of the flexible cord should be appropriate for the environment in which it will be used. For example, oil-resistant cords should be used in areas where there is exposure to oil or grease. Cords with thermoplastic insulation are generally suitable for dry indoor locations, while cords with thermoset insulation are better suited for wet or outdoor locations. Strain relief fittings are essential for preventing damage to flexible cords at the point where they enter equipment or enclosures. These fittings provide a secure connection and prevent the cord from being pulled or twisted, which can damage the conductors and lead to electrical hazards. Strain relief fittings are available in various sizes and types to accommodate different cord diameters and enclosure types. They should be selected based on the specific application and the cord being used. Proper installation of flexible cords is crucial for safety and reliability. Cords should be supported and secured to prevent them from being pulled or damaged. They should not be run through doorways, windows, or other openings where they could be pinched or cut. Cords should also be protected from abrasion and physical damage by using conduit cable trays or other protective measures. When connecting flexible cords to equipment or enclosures, it is important to follow the manufacturer's instructions and use appropriate wiring methods. Connections should be made with properly sized connectors and terminals, and all connections should be tight and secure. It is also important to ensure that the cord is properly grounded to prevent electrical shock hazards. Regular inspection and maintenance of flexible cords are essential for identifying and correcting any potential problems before they lead to accidents or equipment failure. Cords should be inspected for signs of damage, such as cuts, abrasions, or frayed insulation. Connectors and terminals should be checked for tightness and corrosion. Any damaged or worn cords should be replaced immediately. Flexible cords are a versatile and convenient wiring method for many industrial applications. However, it is important to use them safely and in accordance with the NEC and other applicable codes and standards. By following the guidelines and recommendations outlined in this discussion, you can ensure that flexible cords are used safely and effectively in your facility. Remember to always consult with a qualified electrician or electrical engineer if you have any questions or concerns about the use of flexible cords in your specific application. The NEC provides specific guidelines on the allowable ampacity, which is the current carrying capacity of flexible cords. The ampacity of a flexible cord depends on the gauge of the conductors, the type of insulation, and the ambient temperature. It is important to select a cord with an ampacity rating that is sufficient for the load it will be carrying. Using a cord with an insufficient ampacity rating can lead to overheating, insulation damage, and even fire. The NEC also provides guidelines on the minimum size conductors that can be used in flexible cords for different applications. The minimum conductor size depends on the ampacity of the circuit and the length of the cord. Using conductors that are too small can lead to excessive voltage drop, which can affect the performance of the equipment being powered. When using flexible cords in wet or damp locations, it is important to use cords that are specifically listed for wet locations. These cords have moisture-resistant insulation and outer jackets that protect the conductors from water damage. It is also important to use watertight connectors and fittings to prevent water from entering the cord and causing electrical problems. Flexible cords should not be used as a substitute for permanent wiring. They are intended for temporary or portable applications where it is not practical or feasible to install permanent wiring. Using flexible cords as a substitute for permanent wiring can create a safety hazard and may violate the NEC and other applicable codes and standards. Flexible cords should not be run through walls, ceilings, or floors. They should be kept exposed and accessible for inspection and maintenance. Running flexible cords through walls, ceilings, or floors can create a fire hazard and make it difficult to inspect and maintain the cords. Flexible cords should not be overloaded. Overloading a flexible cord can cause it to overheat and damage the insulation, which can lead to electrical shock hazards or fire. It is important to check the ampacity rating of the cord and ensure that it is not exceeded. Flexible cords should be protected from physical damage. Physical damage to a flexible cord can damage the insulation and expose the conductors, which can create electrical shock hazards or fire. It is important to protect flexible cords from being pinched, cut, or abraded. Flexible cords should be properly stored when not in use. When not in use, flexible cords should be coiled and stored in a dry, protected location. This will help to prevent damage to the cord and extend its lifespan. When working with flexible cords, it is important to follow all safety precautions. Always disconnect the power before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and eye protection. If you are not comfortable working with electricity, consult with a qualified electrician. The NEC contains specific tables that list the allowable ampacities for various types of flexible cords. These tables take into account the conductor size, insulation type, and ambient temperature. It is important to consult these tables when selecting a flexible cord for a particular application to ensure that the cord has sufficient ampacity for the load it will be carrying. In addition to the ampacity tables, the NEC also contains specific requirements for the construction and marking of flexible cords. These requirements ensure that flexible cords are safe and reliable for use in electrical systems. Flexible cords must be marked with the type of cord, the conductor size, the voltage rating, and the manufacturer's name or trademark. This information allows electricians to identify the cord and ensure that it is being used in accordance with the NEC. Flexible cords are commonly used to connect portable tools and appliances to a power source. When using flexible cords for this purpose, it is important to ensure that the cord is properly sized for the load and that it is protected from damage. The cord should also be equipped with a grounding conductor to protect against electrical shock hazards. Flexible cords are also used in control circuits to connect sensors, switches, and other control devices to a control panel. When using flexible cords in control circuits, it is important to ensure that the cord is suitable for the voltage and current levels of the circuit. The cord should also be protected from mechanical damage and exposure to moisture or chemicals. In some industrial applications, flexible cords are used to connect motors to a power source. When using flexible cords for this purpose, it is important to ensure that the cord is sized appropriately for the motor's full load current. The cord should also be protected from mechanical damage and exposure to oil or other chemicals. The NEC allows the use of flexible cords for the connection of motors under certain conditions. These conditions include that the cord is not used as a substitute for permanent wiring, that the cord is protected from damage, and that the cord is properly sized for the motor's full load current. It is important to consult the NEC for specific requirements regarding the use of flexible cords for motor connections. Flexible cords are available with a variety of different insulation and jacket materials. The choice of insulation and jacket material depends on the environment in which the cord will be used. For example, cords that will be exposed to oil or chemical should have oil-resistant insulation and jackets. Cords that will be used in wet locations should have moisture-resistant insulation and jackets. The NEC requires that flexible cords be supported at intervals of not more than 6 feet. This helps to prevent the cord from sagging and being damaged. Flexible cords can be supported by a variety of methods, including cable ties, cable clamps, and cable trays. It is important to select a support method that is appropriate for the type of cord and the environment in which it will be used. The NEC also requires that flexible cords be protected from strain at the point where they enter equipment or enclosures. This can be accomplished by using strain relief fittings or other approved methods. Strain relief fittings prevent the cord from being pulled or twisted, which can damage the conductors and lead to electrical hazards. When installing flexible cords, it is important to avoid sharp bends or kinks in the cord. Sharp bends or kinks can damage the insulation and reduce the cord's ampacity. Flexible cords should be installed in a manner that allows for easy movement and flexing without putting undue stress on the cord. The NEC prohibits the use of flexible cords in certain applications, such as in place of permanent wiring, where they are subject to physical damage, or where they are concealed within walls, floors, or ceilings. It is important to consult the NEC for specific prohibitions regarding the use of flexible cords. Flexible cords are an important part of many electrical systems. By understanding the NEC requirements for flexible cords and following safe installation practices, you can ensure that flexible cords are used safely and effectively in your facility. Always remember to consult the latest edition of the NEC and any applicable local codes for specific requirements in your area. Proper selection, installation, and maintenance of flexible cords are essential for ensuring electrical safety and preventing accidents. When in doubt, always consult with a qualified electrician or electrical engineer. Always de-energize circuits before working on them and use appropriate personal protective equipment.